Anyway, graph sets. A couple things we're going to hit today. One of them is graph sets, and then we're going to get into chapter 7, timers. The first part, I think we're going to hit graph sets. So this is kind of where everything comes together. We get into graph sets, we get into timers, we get into counters, we get into latch and unlatch instructions, OTL, OTU. So this is kind of where we begin the word level instructions, timers, counters. We've been talking about bit level instructions all this time. The XIC, XIO, OTE, and a little bit of the OTL, OTU stuff. On Blackboard, there is, and I know everybody looked at this.
Copyright.
Who did look at it? Who had a chance to look at it?
Yeah.
Not a big deal. We're going to go through a few examples. Not a lot there.
Well, yes, there is.
You'll be a graph set expert after today. I hope. That's the point. So we have actions, the squares, and then we have transitions. Actions are always going to be output because it's producing an action. When we refer to PLC logic, it's going to be an output that actually does something. And the transitions are always going to be some kind of either an input or a timer done bit or a counter done bit. The one on Blackboard, I think I had, actually this one too, I didn't correct this one either. I need to take this out of actions over here and put timer, counter done bits, those should be in transitions. Make a note of that.
Make a note of what transition?
Yeah, transition, it says inputs.
Yeah.
It should say inputs and timer and counter done bits.
Timer, counter, and what?
Timer and counter done bits. Yeah, TN.
So we can take it out of the action one?
Yeah, remove that out of the action one and put it in transition. And you'll understand that a little bit more as we move on. So I want to go through a few examples of designing a graph set. And then you guys will get to do one. We'll do one as a class together a little bit later. We'll start with something really simple. We have a cylinder. And I'm going to put a proc switch here. And then a proc switch here. What are the proc switch going to tell the PLC logic?
Contacts or point made positions.
Think about how the cylinder works. Think about the operation of the cylinder.
Because you gave me the retract extended or.
Yes, that's right. So extended procs. And retracted procs. And we're going to keep it simple. We're just going to put a start push button over here. Start push button. We always start out with an initial state, the initial conditions in a graph set. What are the initial conditions of a machine? Yeah. So you're basically at home position. Everything's been initialized, right? As soon as you power up the machine, this is the home. All axes are at some reference point, or all parts of the machine are at some reference point. And then we go into transition number 1. we have transition one, and then we have action one. Remember, transitions are always inputs or timer, counter, done bits, and actions are always what? Outputs, yeah. So what's our first transition? We need to get to action one. We need to, and action one is going to be to extend this cylinder, right? Cylinder extend. What's going to be the first transition? To make this, that's, yep. Start. Push button. And there's one more condition. Yeah, it has to know that it's retracted. The and side, retracted props. Transition one, action one. We go to transition two. What's transition two?
On back.
Yeah, we're just gonna make this thing go back and
Oh,
forth.
okay.
Extended.
Yeah, the extended props. Action two. Cylinder retract. And then we always finish it up with a transition.
Back to home.
Yeah, so this would be retracted props. And then we go back to the initial condition.
So you say always end with the action? I mean, transition?
Yeah, always in the transition.
So that's not going to be transition three, retract, I want to put trans three on that. Yeah.
That'll technically be transition three. Yeah, for the initial conditions. Let's do it up. Good? Let's keep it simple again. So we're gonna run a conveyor. Proc switch, a proc switch, and a start button. We have a load position. And an unload. How do we start? Start push button.
With the transition?
Yep, let's go ahead and do our initial conditions.
Bring it home.
Yep, at home.
And then start push button.
Close position.
and load
Yes.
position.
So we have the start push button,
And then load position,
and
load position.
load position. Action one,
Cycle.
Moves out the bay.
Conveyor.
The bay moves forward.
yeah, conveyor forward, move, unload, yep, however you want to. Conveyor forward. Next transition. We're just gonna run this thing back and forth, we're not gonna stop it, let's keep it simple. Yeah. Unload position props. Our next action. Conveyor reverse. What's our last transition? Yeah. Load position props. We'll do another one, and then you guys work through it. And then we'll do it
Can I take a
together.
picture of that? Me. I couldn't draw if it wasn't printed on.
Let's do another one, and I want you guys to take out a piece of paper and kind of work through it, and then we'll work through it together. We're gonna fill a tank. This is a fill valve, gravity fill. And we have a discharge pump. You have to have some kind of a level switch. I hope you guys have seen these before. Maybe not. Have you guys ever seen these level switches in a tank on a long rod? There's a float on it, that slides up and down. It's kind of old school technology.
Like the toilet, like the toilet.
There you go, yeah. Pull it.
I know I've had to fix that before, so I'm like, oh, it's always that messes up.
When you go to the bathroom, it's going.
Yeah, it's gonna stop wiring.
Yep, change the plug valve. We're gonna have a high level. And a low level. And a start. We're gonna start with a tank full. The tank's gonna be full, and we have to discharge this thing and then fill it back up. Full tank, we empty it out, and fill it back up. So work through it, and then we'll do it together.
I go with the GRAFCET.
Come up with a rest.
I got,
Start with home.
read this out to you. Somebody that might be out of order, because I was thinking about their valves. We went to the first position, the transition to one. Read home and start button.
Okay, so we have the initial conditions. Transition 1.
And, for the second, for the first position, fourth part, this will be number 2, part, is to turn off that valve up top or you want?
What was transition 1 again?
Start.
Start.
Yeah.
And the tank will be full.
High level.
Yeah, high level water.
And yes, high level. Action 1,
Discharge tank.
discharge.
I put drain, it's almost the same.
Drain. Yep, pretty much,
Transition two.
transition two.
The low level.
Low level. Action two,
Pump will turn off.
pump off. Yeah, we can do this all in one action. Pump off.
Discharge closed?
Yeah, yeah. Pump off. And valve on. What transition did you have after pump off?
After that, I had high level, it returns to, the water returns to high level or the tank fills again.
Yeah. So we reached a low level, turn the pump off, now we're gonna start filling again.
Is it a pump or a drain?
Fill solenoid, it's a pump.
Okay,
We're doing a manual fill with a valve,
okay.
and then the fill solenoid. And you can put you can put a lot of detail in this stuff too, can't you? You can see, okay, we have pump off, and then we verify that the pump's off, and then we verify the pump's off. So we can, as soon as we see the motor starter auxiliary contacts open up, right, that would be a transition. We do a pump off, shut the pump off, the auxiliary contacts open up. So, yep, pump's off, then we can turn on the solenoid. There's, you get pretty detailed with this stuff.
I think that's my problem, I was overthinking, because I was thinking if that valve is not closed, then you could potentially have water coming up.
Right, and a lot of times, this is kind of a high-level overview of, it's basically a sequence of operations that you would see on a machine, for a machine. If anybody's in any kind of a factory's environment, you open up your electrical press, the first few sheets are gonna be a sequence of operations, right? Index, sequence of operations, or GRAFCET. And then, on after that, power circuit, control circuit. So yeah, we can do 2 actions in one. Technically, before we start filling this thing again, yeah, we want to know that that pump's turned off. No, we need to fill, pump's not turned off. Action 3? Oh,
What's
we don't need,
transition two?
we don't need another action, do we?
What's transition?
Yeah, that's right. Like I say, you can get as detailed as you want with this stuff. Well, you get it, that's exactly right.
So there will be
No transition three.
Transition 3 is gonna be,
Erase.
high level.
high level and return to home.
Yes, there we go. Yes, pretty much it. Pretty much it. Now, we can also have or statements in the GRAFCETs. And you'll see that a little bit. Let's go through an example. But it is something to keep in mind. Is everybody good? Yes. Here would be an example of an or statement in a GRAFCET. We have a conveyor. And this conveyor, see what's going on here, right? It can have parts that go in either direction, right? So let's say we have a sizing station right here. We're sizing these parts. We have a photo eye. It's shooting across this conveyor. We're sizing different heights of parts. let's say we wanted to send taller parts this direction and short parts this direction. We had to have some kind of a divert.
right?
Yeah, something to divert the parts either one way or the other. Yeah. Something like that. Proc switch here, know that it's full. Proc switch here to know that this one's full. We have a proc switch here to know that we want the entrance of this conveyor section. Proc switch here to know that we want the entrance of that conveyor section and so on. So there can be a lot going on. And just to give you a quick example, let's do a start button. We're not going to go through this whole thing. So we have the initial condition. Transition 1. What's transition 1? Start. And part present, whatever, yep, part at entrance, whatever, part. I'll try to keep it short here. Part present at the entrance of the conveyor. Action 1. Turn on the conveyor, right? Conveyor on, or something like that. Transition 2. Yeah, we got something going on here at the sizing station before we divert the parts one way or the other. So, sizing. Sizing, photo eye, vision, whatever we're using there. And then at that point, that's where the or statement comes in. What's the next action's going to be? And here's how it would come out. On the left side, you would go 2, 3, 4, 5, 6, 7, and so on. On the right side, it would pick up. Let's say we have 2, 3, 4 actions over here. Then we go 5, 6, 7 on the right. Make sense?
Yeah.
But either way you go, you're still gonna return that home.
That's exactly right, yeah. So in action 2 here, it's either going to divert the tall or divert the short. However you set it up, right? So we'll just say divert the tall. Divert the short. And I'm going to keep it simple because I'm running out of board. And then at the end of the or statements, we do that, and then go back to the top. Everybody kind of have an idea? And that's not the full graph set for that, but it gives you an idea.
There's not full grass set there.
Yeah, no. Maybe that'll be an exercise later on for you guys to finish up.
So that,
Oh, here you go.
the next one would just be transition prompts for trans 3. Transition
Yeah,
out of the
so you-
conveyor into the next station.
That's right, you would take the part here and then turn on the conveyor and run it out. Yeah. Proc switch, yeah. Or you could also have some kind of verification that this thing actually diverted, right? Have some kind of a proc switch here to say, yep, we are actually diverted. And a lot of times those things fail. Put a little diversion, they will fall off or something will happen.
Yeah.
We're gone. Anyway, give you an idea. We gotta jump into chapter 7, guys. We're getting behind. We still have some practice and labs we gotta work on. But you'll get through it, no problem. Chapter 7. We were talking about word level instructions, and that's kind of where we get started in word level instructions. A little bit different than what we've been using. So we get into timers.
You did on chapter 7, right?
Yeah, chapter 7. And the first part of this, what we're going to talk about, should be all review for everybody. So you should have already gone through all the mechanical timers, mechanical timer relays, and that type of stuff. So hopefully, I'm hoping it's review. Has everybody been around wired up mechanical timer relays? Good. Yeah, get some of these guys that are in night classes, don't even know what I'm talking about. So that's why I asked the question. And I always start where I'm just under the assumption that nobody knows it.
Good, good.
Not that weird.
That's good. All right,
It kind of works. So in the PLC instruction world, we have the TON, the TOF, and the RTO for timers. And we're going to go through each one of these. The TON is the on-delay timer. The TOF is the off-delay timer. The RTO is the retentive timer on. Now let's go back, and I want to compare the two. Compare the relays, the actual relays with the instructions. TD, does everybody understand what TD stands for? Time delay, yeah. Time delay. TD1, I'm going to do it on delay timer. Anybody remember what the contacts even look like? Nope. Let's do it on the open set of contacts. Arrow up. What's that contact called? We know it's we know it's a normally open, right?
Time closed.
Normally open, yeah, time closed. And then we have the normal close. Time open. Yeah. That's the on delay. So we press the button. Right? Let's say we have this set for 5 seconds. We press the button. We're timing. 5 seconds later, the normally open time closes. Everybody good with that? On the normally closed time to open, we press the button. How does it work?
It's going to stay closed until 5 seconds later.
Yeah.
On today.
Yeah.
It's like name count open.
On the way. What percent?
So these are strictly, in the other examples, we did the bit relays. So these are strictly going to act just as effectors of the inputs and not necessarily as bits.
Right, yeah, that's right. These will be inputs, PLC, yeah. So we have on delay contacts and then off delay. What's that one? We know it's normally open. Normally open. Yeah. Time open, right? And then we have the normally closed. Normally closed. time closed, right?
Same kind of drill.
So we press the button. We're gonna do it off the way. We press the button on the normal, in the normally open, timed open. Press the button, what happens to this contact? Yes, it's gonna close, right? As soon as we press the button, as soon as that relay gets energized, it's gonna close. Instantly. Then what? When does it start timing?
When you take your finger off the button.
That's right. As soon as we de-energize that timer, that's when it starts timing. Times for 5 seconds, after it's de-energized, and it opens up. Good? Clear as mud?
That's without the ceiling.
And you said that's on delay or off delay?
This one's on delay, and this one's off delay.
Okay.
About the normally closed, time closed.
It opens instantly,
Opens instantly.
sometimes closed when you de-energize it.
Yes, time closed when de-energized. Good? I hope this is a review for everybody. There are also a couple of other sets of contacts in a timer relay too. All of them don't have it, a lot of them do. And those are these. They're instantaneous contacts, just like a regular control relay. So they close and open based on when the timer relay is energized or deenergized. Instantaneous and then time. The TON instructions, actually, that's the best way to do it. In the,
What did they do?
megaphone or what? Oh, Fitzgerald?
Yeah,
No,
yeah.
no wonder.
Things was too quiet in here for him.
Huh,
Things was too quiet in here for him.
I think so. So in the PLC instructions, we have contacts. They're not really contacts, they're status bits. Status bits, control bits. Those bits are timer timing, the enable, and the done bit.
What did you say those are?
The time
Status bits, control bits.
Control bits?
Yeah. Actually, the textbook says control bits. Alan Morelli calls them status bits. That's why you call them.
And what was the D you did?
I learned the status bits. Done bit.
Completed.
Exactly. That's exactly right. Timer time. Enable. And we're done. Yeah, that's exactly what it is. So we set up, I think the best way to do this. The timers are all addressed from the timer data file, the T4 file. It's data file number 4.
T4 file.
T4, yes. here are the status bits: enable, timer, timing, and done. And there's also a preset value, just like a timer that you would dial in, whatever, you wanted the time for so many seconds. You adjust the preset on it. And in the instructions, there's an accumulated value. So you can see that the accumulated value has its timing, the accumulated time. Yeah, increments, yeah. Uh-huh. Yeah, yeah. Well, let's take a look at it. So when you set up a timer instruction, you have the timer number. This one's T40. The time base, and you've seen that on some relays, little thumb wheel stuff. That little, you know what I'm talking, yeah, little 3-digit, 4-digit, 3-digit. In the instructions, you see the time base. So I'm gonna set up the time base. I'm gonna set it to 1. That means seconds. Yes. How many seconds?
1.
We have a time base of 1 second, and then we have a preset set to 10,000.
So that's 10,000 seconds.
Yeah. So on the time basis is one, you really, 10,000.
Yeah, that would be like 10,000.
Say if I do 20,000.
Well, it's only in increments of
1 0.
ones, tens, hundreds, thousands, time bases.
What's the increments of again?
This time base, it's like hundreds and thousands.
Oh, okay.
100s and thousands. Now, let's set it to 0.01. How many seconds is that going to be? Yeah, 100 seconds, right?
Yeah.
Just move the decimal point over, and then you can either do it that way or you can multiply. 10,000 times 0.01. And we have thousandths of a second. Big time seconds. That would be 10 seconds. Yeah, that's right. What do you think what do you think we can, what's the maximum number you think we can go to? Remember, these are word level instructions. Word level. Remember that word level of all 16 bits?
So you go 16?
32,767?
You go there?
Well,
You can go there?
yeah, you can go way up with these things. So you could go 32,000.
Wait.
32,000, yeah.
Like the old Pac-Man game.
That's what he got before.
Let's watch these for a minute. Watch the status bits, watch the timers. So I'm going to energize that first timer, the on-the-way timer. Watch the stats bits over here. Enable, timer timing, done bit. Timer's enabled. The enable bit gets set anytime it gets energized. Timer is enabled. And you see the timer timing bit? It gets set while it's timing. So as soon as the accumulated value reaches the preset, the timer timing bit goes back to 0, and we get the done bit. Let's watch it again. Got the enable bit, the timer timing bit, the timing, timing. Timer timing bit goes back to zero, the done bit gets set.
So no three bits are active at the same time with these. It's either, you either have one or the other.
Yeah. Yeah. That enable bit is all based on having logical continuity, yeah. Yeah. So if I'm doing this, let's watch the timer on. I'm going to enable the timer. That's T41. Done bit immediately, just like the contact's closing. All right. On normally open time. Think about it. Yeah, think. Normally open time.
Yeah, it turned out.
Yeah, now I'm gonna, now I'm gonna turn it off. Now we start timing. We still have the done bit. We're timing, timer. Done bit for 10 seconds. Yes. Let's watch it again. Done bit immediately. Enable bit. Just like the contact. With the retentive timer, there's also another instruction you have to use. That instruction is a reset instruction. Since it's a retentive timer, the only way to reset it is use a reset instruction. For the other two instructions, all you have to do is make the run go false to reset it. Yeah, that's right.
So I got to push.
Yeah, just, I got it on, push button for the reset instruction. Yeah.
So I can make, you press.
So you have non-retentive timers. How do they get reset? The run goes false. Just make the run go false and then reset. Retentive timers require a reset instruction. Let's watch and the retentive timer on is just like the on delay timer, except you have to reset. We're timing. We have the enable bit, timer timing bit. We get the done bit, timer timing goes low. Here's the difference. It didn't reset when I de-energized, right? I'm going to reset it. I'm going to start timing again. Start timing. I'm going to stop timing. See what, so it retains the accumulated value. If the done bit is set, it retains that also. Now, let me do this. I'm going to shut the power off. There we go, time's up, lost communications, okay. We'll turn the power back on. Boot up.
Mr. Ham, does that mean that the retentive timer has feedback?
Not really, it just retains its last state. Retains the accumulated value. Now, I'm gonna start timing again. Got the done bit. Done bit stays on. Everybody's good with it? So it contains the accumulated value and the status of the done bit. Okay, we got to roll along. 10:37.
You said the unretentive timer requires false alarm? Unretentive? False alarm.
Yeah. Yeah, so the non-retentive timers, they get reset.
So retention is stored in the ROM.
Yeah, I guess it was, yeah. That makes sense. Yeah. The same thing happens on an OTL instruction. The output latch, it's a retentive instruction also. That, I'm gonna get rolling on some cracks now. Yeah, we got plenty of time, so let's get that. We'll get into some other stuff later on. Yeah, we'll get into some regular applications of using the timers. Let's work through some practice labs here. There's 4 we gotta get done today. They are due at the end of class. Great. But you will have plenty of time to work through them. We have 7-5. And let's, I want to talk about each one of these real briefly, and then you can, then you're off and rolling.
Which page in the lab book?
There's 52. 7-5. So all you're doing in 7-5 is setting up an on-delay timer, and it's walking you through checking the status bits and learning how they actually work. Not a showstopper. 7-6. What is 7-6 actually doing? I want you to take a look at the diagram and tell me what we're doing with that.
Motor on after 5 seconds.
Yeah, so it's a startup delay, right? Real common logic. Having startup delay. You have to hold in on the button for 5 seconds before it starts up. What that does is that prevents an operator from just going and bumping the button, the start button, right? Turn it on a machine. So it's a start delay. You add in a little bit of delay time to start up a machine. 7-7. Take a look at it. What's going on in 7-7?
You're using a control control relay to turn your timer on. After 10 seconds.
These are all potential
Your
test
horn.
questions, guys.
Use
You
your
may
mouse.
want to
10 seconds.
really look this stuff over.
Your horn's gonna sound for 10 seconds. Or no, after 10 seconds.
Is your reset basically your stop button?
Yeah. Yeah, so the horn's gonna sound for 10 seconds, right? It's like a startup warning, right? Typical, real normal machine type stuff. It's got some kind of a startup warning. The horn sounds for 10 seconds and then the machine starts up. Hey, I'm starting up, get out of the way. Don't be asleep. 7-8. What's going on with 7-8? Look at the relay line.
Just grinding the motor.
Basically, yeah. So we got this loop pump, right? Start the loop pump, and this loop pressure switch has to be made, right? So it has to be up to some pressure. This oil pressure has to be at some level before we can start the main drive motor. And then, after the main drive motor starts, then we
Timer
start.
also starts in after 15 seconds.
Yes. We start a feed motor. So they're using they're using this to prevent burning up the motor, right? They're lubing some kind of a bearing or something.
Do we need to put the overloops in that?
No.
Excuse me, I'm sorry.
Timer